I'm going to take a look at this proof. The given information, I'm going to try to mark as much as I can in the diagram. And you can see here that PR is congruent to ST. So I've got those two segments congruent to each other. I'll mark those. I also know that NP is congruent to VT. So I'll add that to the diagram as well. And in addition, I know that angle P is congruent to angle T. When you're doing these proofs, you need to be very careful. If you've got overlapping triangles, you need to make sure that the congruent parts you have are full sides and full angles of the triangles you're trying to prove congruent. And you can see here I've got a problem because PR is only part of a side, ST is only part of the side. I need to show the entire side, PS, congruent to the entire side, RT, if I'm going to prove these triangles congruent, okay? I really also need to take a look at what I'm trying to prove. You can see here that I'm actually trying to prove the triangle WRS is isosceles. I've got two options to show that that triangle is isosceles. I can show the two sides are congruent, but you can see that those aren't sides of triangles that appear to be congruent. Meanwhile, I can prove that two base angles are congruent. And if I can show that, I should be able to use these two overlapping triangles. If I can prove them congruent, their angles, this angle right here and that angle right there, are angles of the triangle that I'm trying to prove isosceles. So that's going to be my approach. So how does that work? Well, a few things here. First of all, I need to prove side PS congruent to side RT to prove those two triangles congruent. And the way I can do that, you can see side PR needs to have side RS added to it to become PS. TS needs to have RS added to it to become side RT. Well, that's the addition property. I'm adding the same segment to two congruent segments to get new congruent segments. So PS is congruent to RT, and that's the addition property. And now, if I take a look at my triangles, you can see I've got this segment here congruent to that segment. If you look at your overlapping triangles, I'm really trying to prove this triangle congruent to the overlapping triangle on the other side. Sometimes you might want to draw these triangles separately, put the labeling on it separately. I'm not sure that that's really an issue in this case, but I'll do it here just to make the point. This is triangle NPS. And now you can see my labeling here. I've got NP labeled, I've got angle P labeled, and I have the entire side PS labeled. That's a side angle side congruence for the two triangles. So I'll add that into my proof. Also, you want to make sure that you have all sides and angles that you're using for your side angle side statement included as congruent statements in your proof. So I'm going to go back here and check. PS congruent to RT, that's a pair of sides. Angle P congruent to T, that's a pair of angles. And then finally, NP congruent to VT, that's a pair of sides. So it doesn't have to be in order in the proof, but it does need to make it there. So I can say the triangle PNS is congruent to triangle, it's PNS, it's going to be TVR. And that is by the side angle side rule. And to finish, remember I'm trying to show that triangle WRS is isosceles. I either need two congruent sides, which again are not full sides of the two triangles I proved congruent, or I can use two congruent angles. And you notice here in triangle NPS, this angle right here now is going to be congruent to this angle over here, because those are corresponding parts of those two congruent triangles. So, I'm going to state that angle NSR is congruent to angle WRS. Okay, those are corresponding parts of congruent triangles that are congruent. And now I can make my conclusion, because triangle WRS has two congruent angles. So triangle WRS is isosceles. The reason being, if a triangle has at least two congruent angles, it's isosceles. Take a look at the data that I've got here. I'm told that segment AD is congruent to segment BC. I'm going to label that on the diagram there. DAB, and that's this entire angle on this side, is congruent to CBA over on the other side. I'm trying to prove that triangle ABE is isosceles. Keep in mind, to prove that I have an isosceles triangle, I need to show either that that triangle has two congruent sides or that the triangle has two congruent angles. So the first thing I want to do here is look and see, do I have triangles that I can prove congruent? And you can see several different triangles that might be able to be proved congruent. You can see these two triangles right here. You got vertical angles congruent. The top and bottom triangles don't appear to be congruent, so not very likely. I've got these two overlapping top triangles, and you can see that I also have two overlapping bottom triangles. And if you look at the given information, I was given an entire angle here, an entire angle here, a side here, a side here. I should be able to show these two overlapping triangles congruent. And specifically, I'm looking at DAB, which is this triangle right here, and triangle CAB going the other direction. Those overlapping triangles. When I do overlapping triangle problems, I like to draw at least one of those problems, one of those triangles separately, so I can see which parts I've proved congruent when I'm working with my congruence rules. So I'm going to show a DAB by itself, and I'm also going to put the labelings on that triangle. So you can see I've marked a side here, I've marked a full angle, and the other piece of information here, these two overlapping triangles share a side. When you have overlapping triangles, you almost always are going to have some shared part, whether or not it's a side or an angle. So we have a reflexive property case here, and you can see the two triangles can be proved congruent by side angle side. So I need to add those steps into the proof. These were given, they're listed as part of the givens already. The shared side, AB congruent to AB, not included as part of the original proof. That's the reflexive property. All right? And you can see that already the two overlapping triangles can be proved congruent by side angle side. So I'm going to name those two triangles. That's triangle DAB, and it's congruent to triangle, it's DAB and CBA. And once again, that's side angle side. You should make a check, ensure that you've actually included all of the congruent parts that you need to include. AD and BC, that's a pair of sides. DAB and CBA, that's a pair of angles. AB and AB, that's a pair of sides as well. And so you can see that I have in fact included the segments and angles that I'm supposed to. The last part, I have to prove that this triangle is isosceles. Either I have to prove AE congruent to EB, but if you notice, AE, not a full side of this triangle, EB, not a full side of that triangle. I need to look at those triangles, I need to find sides or angles of my congruent triangles that are complete sides or angles of this triangle right here. And hopefully you notice, if these two triangles that are overlapping are congruent, this angle right here, that corresponds to this angle right here, is going to be congruent to this lower angle right here. And if I'm able to do that, that shows that the base angles of my triangle are congruent, which is going to force that to be an isosceles triangle. So, I'm going to state that angle EAB is congruent to angle EBA. And that's because corresponding parts congruent triangles are congruent. And at this point, I am more or less done. I've shown that this triangle has two congruent angles. That tells me it's isosceles, so I can say that ABE is isosceles. The reason being that the triangle has at least two congruent angles. So the angles definition of isosceles is what I'm using here. Then I'm allowed to say that it's isosceles. So if a triangle has at least two congruent angles, then it is isosceles. And that ends my proof.